Python is an important programming language for every aspiring data professional and data science person or company all over the world use Python to harvest insight from your data sets and gain a competitive advantage against other companies or other competitors. So welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python programming language over the next 100 days. Today is day 12. We've started this learning journey a couple of days ago. We've done from day 1 all the way till today, which is day 12. We started with introduction to Python, where we actually looked at Python data types, variables. We learned all about lists in Python. We also learned about packages in Python, and we got introduced to our first Python package, which is the NumPy package. Then we moved to intermediate Python, which is what we actually learned. The next course we're actually on now, which is intermediate Python. And we actually started with matplotlib for data visualization in Python. Then we move to dictionaries and pandas, which is one of the two to work with tabular data with in Python. That is your CSV files, your normal CSV files. You connect to the data set, then you start working with it with um, dictionaries and pandas in Python. So dictionaries, from dictionaries, you can create a pandas data frame. But when you have your data set in a CSV file, you can just easily use pandas to connect to it and start working with pandas in Python. Then we are on a course actually now called control flow or control flow and filtering in Python, which is using comparison operators while working in Python. Let me show you what all that looks like. So if you want to catch previous lessons or from the that we've covered on Python, you can go to the live stream tab on the channel. You see tons of lessons on Python all the way from day 1. So we've not gone too far. Today is just day 12. So you can still catch up from day 1 to day 11, which is just like an hour for each live stream. So a total of 11 hours of learning and practicing. You'll catch up with us here on today's live stream. So if I go to the career tag section real quick, if I go, you can see we are on data analyst with Python. When this one way of learning started, it actually started with data analyst in SQL. Then we moved to data analyst in Power BI. You see, so we've completed data analyst in SQL and data analyst in Power BI. I'll be sharing some of my projects or make a well or comprehensive video on those projects pretty soon. And this kind of takes time to do all this shooting, editing, and recording. If you are the only one that run your stuff yourself. But we are on data analyst with Python. If I click on this, you can see we're just 70% throughout the whole career track, and we've completed introduction to Python, which is the Python basic list, function and packages, the NumPy. Then we are on this intermediate Python. So we've covered matplotlib, we've covered dictionaries and pandas. Also, all the data sets, CSV files, like you'll be using to practice with me, is already linked under the YouTube description. So do make sure to download those files and practice along with me. So without further ado, let's jump back to learning and welcome back to day 12 of our Python learning journey. So I'll just click on continue from here. Let's view course real quick because we've covered a couple of topics before on this control flow. And so we've covered comparison operators, how to use the and or not, the Boolean operators. So they are straightforward operator that you are actually familiar with. So I'm moving to the if else, if else. That's like the if statements in Excel. If you know if this, then this, if this, value if true, value if false. So similar scenario can happen in Python. So I'll just click on continue chapter from here. See why that is coming up. I'll go ahead. You can see we've covered a couple of before from day 11. So you can easily just catch up on all this from day 11. We are moving to the if else statements, just like the then statements in Excel that I'm quite familiar with. So also, I have my Jupyter notebook launched already. Let me just launch that real quick here. So to learn how to download this Anaconda Navigator, you can go ahead and watch day 1 live stream where I showed you how to download this Anaconda Navigator, so you have access to the Python environment you will be using to learn. Oops, this is still coming up. I think I launched this. Let's see. Oh, you can see, so it's going to launch my Jupyter Notebook on the web browser. Well, that is still coming up. Well, let us just continue. Let us just continue from here. Just a seconds, very quick. Sorry about that. Okay, let's continue our journey here.
So you know about comparison operators now, such as less than and greater than. And you also know how to combine the Boolean results using Boolean operators such as and or. Things get really interesting when you can actually use these concepts to change how your program behaves. Depending on the outcome of your comparisons, you might want your Python code to behave differently. You can do this with conditional statements in Python: if, else, and elif. Let's start working in a script, control.py. Suppose you have a variable z equal to 4. If the value is even, you want to print out z is even. This code does the trick. Modulo operator 2 will return 0 if z is even. If you run this, Python checks if the condition holds. It's true, so the corresponding code is executed. Z is even gets printed out. Let's compare this to the general recipe for an if statement. It reads as follows: if condition, execute expression. Notice the colon at the end and the fact that you simply have to indent the Python code with 4 spaces or a tab to tell Python what to do in the case the condition succeeds. To exit the if statement, simply continue with some Python code without indentation, and Python will know that it's not part of the if statement. It's perfectly possible to have more lines inside the if statement, like this, for example. The script now prints out 2 lines if you run it. If the condition does not pass, the expression is not executed. You can see this if we change Z to be 5 and rerun the code. There's no output. Suppose now that you want to print out Z is odd, in this case. How do you do this? Well, you can simply use an else statement like this. If we run it with Z equals to 5, the condition is not true, so the expression for the else statement gets printed out. The general recipe looks like this. For the else statement, you don't need to specify a condition. The corresponding expression gets run if the condition of the if statement it belongs to does not hold. You can think of cases where even more customized behavior is necessary. Say you want different printouts for numbers that are divisible by 2 and by 3. You can throw some elifs in there to get the job done. Take this example. Can you tell what this script will print out if you run it? If Z equals 3, the first condition is false, so it goes over to the next condition. This condition does hold, so the corresponding print statement is executed. Suppose now that Z equals 6. Both the if and elif conditions hold in this case. Will 2 printouts occur? Nope. As soon as Python bumps into a condition that's true, it executes the corresponding code and then leaves the control structure after that. This means the second condition, corresponding to the elif, is never reached, so there's no corresponding printout. Control flow can be extremely powerful when you're writing your own Python scripts. Get some practice with it in the exercises.
Okay. I think control flow are pretty straightforward here. So to experiment with if and else a bit, I will look at this code sample below. But I think I have the code sample already launched. Let me open my Anaconda the Jupyter notebook here. Let's see. Okay. So which is logic, control flow, and filtering. And it actually all started with simple control flow, which is the and. You can see this is all we did on this was all we did on day 11, just using comparison operators and or and not. And the control flow, this control flow, if, elif, and else, all started from here. You can see that. So it says to experiment with if and else a bit. I will look at this code sample. Area is equal to 10. The area is equal to 10. So if area is less than 9, it is going to print small. So this area, it is not less than 9. So it's going to skip this expression and move to this second elif statement here. If area is less than 12, print medium. So it can see the area is less than 12 here. So we're expecting it to print medium. And 10 is less than 12. It should print medium. So the answer should be medium here. Else print large. So it has already meets this conditional statement. It's going to print out this expression and not bother about this last expression, which is print large here. Let's submit answer. Great. So it was the same code we actually ran here. Let's see if I run this code again. It's going to return medium. Okay, let's continue. So it now says exercise if. So it is time to take a closer look around in your house. Two variables are defined in the sample code room. A string that tells you which room of the house we are looking at, an area, the area of that room. So two variable room, we are looking at the kitchen and the area of the kitchen, which is 4.0. So it now says instruction. Examine the if statement that prints out looking around in the kitchen if room equals to kids. Write another if statement that prints out big space if area is greater than 15. Okay, if statements for area. Okay, the first one says for if statement for room. If room is equal to kids, print looking around in the kitchen. Then the second one now says if I want to type another if if area is greater than so if area is greater than 15, it enter you're going to indent with 4 space 1 2. So just okay 1 it's going to so that means all the space there is equal to 4 tab easily like that. Okay, I'm curious how it's going to look out in Jupyter Notebook here. So I'm going to it is so since it's no it is if so it indents 4 spaces after that after the if statement under the if statement rather. Okay, now let's see. Say if area is greater than 15, print out big place. So going to print out big place with exclamation mark. If we run the code, let's see the result we have. Oh, hold up in minute. If area is greater than 15, hold up a minute. You don't have to wrap it in brackets. Let's see, but we don't have to wrap it in bracket though. Let's run it again. Oh, okay. Oh, I didn't use this column here to signify that was a mistake there. And let's run it better. Now it runs successfully. You see, so I missed this column here. You see, if room is kids, print out looking around in the kitchen. If area is greater than 15, print out big space, and our area is less than 15. So you're going to get that result there. So great. Big place wasn't printed because area greater than 15 is not true. Experiment with other values of room and area to see how the printout changes. Let's run this similar code on Jupyter Notebook. Okay? So let's see the one that's going to get printed out. The room is 8, area is greater equals to 14. If you run the code, just looking around in the kitchen, this other big place does not get printed because the area is less than 15 here. Okay, let's continue. Add else. So let's take our code to the next a little bit a step further rather. So in the script, the if construct for room has been executed with an else statement so that looking around elsewhere is printed if the condition room is if the condition room equals to kids evaluates to false. Can you do a similar thing to add more functionality to the if construct for area? Okay, just give me a second there. Quickly want to check up on a message. Mm, okay. All right, so let's continue. Now it says add an else statement to the second control structure so that pretty small is printed out if area is greater than 15 evaluates to false. So the first one here says define variables room is equal to kids, area is equal to 14. So if room is equal to kids, you're going to print out looking around in the kitchen, else print looking around elsewhere. So the room here is equal to kids. So expecting this first expression to get printed out. While the other one says if area is greater than 15, that means the area is a big place. Else, well, that's add an else statement here. Else semicolon, then print out uh pretty small. So the area is pretty small. Pretty small. Then if you run the code, you can see so the area is less than 15. It's going to return pretty small here. Let's test out the same code in Jupyter Notebook right here and see what gets printed out. And see the second statement right here gets printed out. As while looking down the kitchen gets printed out here. Okay, interesting. Let's submit the answer. Ooh. Check your call of print. Did you correctly specify the first argument expected pretty small? Oh, I didn't spell my pretty small correctly. That's bad. Now let's submit it now. Oh, wait on a minute. Pretty small. Go on. Let me just copy. Oh, probably because I'm missing a full stop there. That's quite interesting. Now let's try it again. Let's submit it this time around. Exactly. So I have to be pretty careful because of the way it has been programmed here. Let me just copy this code and use similar spelling with a full stop. Let's run the code again. So we have pretty small there. All right, let's continue. So customize further with elif. So I want to make it a little bit advanced. Give me a second real quick. Okay, so let's continue with the challenge. It's also possible to have a look around in the bedroom. The sample code contains an elif part that checks if room equals bed. In that case, looking around in the bedroom is printed out. It is up to you now. Make a similar addition to the second control structure to further customize the message for different values of area. So add an elif to the second control structure that medium size nice is printed out if area is greater than 10. Okay. Now we have this statement saying if room is equal to kids, print looking around in the kitchen. Elif room is equal to bed, print looking around in the bedroom. Else print looking around elsewhere. But in this scenario now, we're expecting it to print out this first expression because the room here is equal to kids. Then the second statement here says, if area is greater than 15, print big place, but our area is less than 15. So else prints pretty small. We are now asked to add an elif statement. So we're going to add an elif statement right just here. Elif. So you're going to print out our if area is greater than 10. So we're going to say if area, elif area is greater than 10, semicolon, then print out medium size. Let me just copy this very quick here so I won't make similar mistake here. It's going to print out medium size right here. Now let's run the code to see. Great, medium size, nice. So since our area here is greater than 10, which is this area right here, you're going to print out medium size, nice. So pretty straightforward if then statement there. We nailed it there. So let's try it out in Jupyter Notebook here. So we're pressing the same code, define the variables, then you're going to print out two code, looking around in the bedroom for this first expression here. Then for this second expression here, print medium size, nice. Interesting. Filtering pandas data frame. Now let's take it up further to filtering pandas data frame. We're just like 30 minutes, less than 30 minutes into the live stream. So we still have a little bit of time to complete this part of the course. Now let's be short and actually use it on the real world data sets. Let's see.
In previous videos, I gave some examples of how the NumPy array can be useful to do comparison operations and Boolean operations on an element-wise basis. Let's now use this knowledge on the pandas data frame. For starters, let's import the bricks dataset again from the CSV file. Here it is. Suppose you now want to keep the countries, so the observations in this case, for which the area is greater than 8 million square kilometers. There are 3 steps to this. First of all, we want to get the area column from bricks. Next, we perform the comparison on this column and store its result. Finally, we should use this result to do the appropriate selection on the data frame. So the first step, getting the area column from bricks. There are many different ways to do this. What's important here is that we ideally get a pandas series, not a pandas data frame. Let's do this with square brackets, like this. This local alternative and this iloc version would also work perfectly fine. Next, we actually perform the comparison. To see which rows have an area greater than 8, we simply append greater than 8 to the code from before, like this. Now we get a series containing booleans. If you compare it to the actual area values, you can see that the areas with a value over 8 correspond to true, and the ones with a value under 8 correspond to false now. Let me store this Boolean series as isHuge. The final step is using this Boolean series to subset the pandas data frame. This is something I haven't shown you yet. To do this, you put isHuge inside square brackets. The result is exactly what we want. Only the countries with an area greater than 8, namely Brazil, Russia, and China. So let's summarize this. I selected the area column, performed a comparison on this column, and stored it as isHuge so that I can use it to index the bricks data frame. These different commands do the trick. However, we can also write this as a one-liner. Simply put the code that defines isHuge directly in the square brackets. Great. Now, we haven't used Boolean operators yet. Remember that we use this logical AND function from the NumPy package to do an element-wise Boolean operation on NumPy arrays? Because pandas is built on NumPy, You can also use that function here. Suppose you only want to keep the observations that have an area between 8 and 10 million square kilometers. After importing NumPy as NP, we can use the logical AND function to create a Boolean series. The only thing left to do is placing this code inside square brackets to subset bricks appropriately. This time, only Brazil and China are included. Russia has an area of 17 million square kilometers, which doesn't meet the conditions. I hope these examples have shown you how easy it is to filter data frames to get interesting results. Get some hands-on experience in the exercises yourself. And I'll see you in the next chapter, where we'll get even more of our control flow on.
Oh, this is quite interesting. Use the idea of to filter data sets. Now let's see it in action real quick though. Let me check about the message real quick here. Okay. Now let's see how we can use this knowledge on pandas data frame. So driving rights. So let's go back to our actual data set real quick. Do we still have it here? We don't. We have to connect to it right here. Let me see the data frame. If I go back to dictionaries and pandas right here, you can see that we have a cars CSV file here. So I want to connect to this file within the same directory here. So it will be easy for me to connect to that. So I could just go to, and we have our packages imported. So let me just point to the data set real quick. Where is it? Pandas right here. So I'm not going to use this, my dear. I'm going to use come on. This class P, you can see I'm going to use this class P pd.readCSV. This class CSV right here. We're going to connect to it for our analysis here. Control C, so I'm going to paste it right here and run the code. See, PD is not defined. Okay, I have to run all this code all the way from here one more time. Let's see, let's run the code. Because I opened the file again, so I have to run those line of code one more sometime because it was not active again since I've closed it the last time. Okay, we are getting there. Now if I run it now, you can see I won't get those errors. That's because I didn't run this my packages before. Now if I call on cars now, if I call on cars, I should get this result here. You can see. So same thing we did all the way here. You see, so I'm just going to close. Let me just leave it open. I may need some code there. Now let's continue from. I see this our data set just contain 4 columns. The column 1, column 2, column 3, column 4. So probably it is actually 3 columns that we have here. We only just use this empty column that was in names. But if I open the, if you have access to the data file, to the CSV file, follow the link under the YouTube description. You'll see the content of the CSV file before you actually connect to it in Python. So it says, remember that cars data set containing the cars per 1,000 people and whether people drive rights for different countries, which is country, because we have cars per capita, drives rights, and the country. just like we could see right here. Now it says the code that imports this data in CSV format into Python as a data frame is included in the script. So we've done that right here. So in the video, you saw a step-by-step approach to filter observation from a data frame based on Boolean arrays. So let's start simple and try to find all observation in the cars where drive right is true. So drive right is a Boolean column, so you have to extract it as a series and then use this Boolean series to select observation from cars. So extract the drive right column as a panda series and store it as dr. So extract drive right column as a series. So as a series, I'll just say dr equals to, I just point to dr equals to cars. So I'll point to cars column. I may not even need to, okay, I'm going to store it as a series. If I say cars, then open a column. So I want to point to the drives right column here, which is column index, which is the last column. I could just use the drives right, the column name, and just paste it there in a semicolon. Oh, let me copy this one more time. Now let's try it out in Jupyter Notebook first to see if the code works fine. So I want to return this drive right column. So I'm using dr, I'm saying that as a variable equals to drive right. Let's see. Oh, so if I call on it now, if I call on dr, you see I have my results. But it's supposed to be returning only just one column. I don't know why it is returning the two column, which is this other index column here that we have here. Okay, if I don't include this index column from the beginning, let me just delete this so you understand what that index column does. If I call on this column like this, you can see it's going to index the column using integer 0 to 6. But I want you to use this first column, this index notation here. So that we have that index here. If I run it one more time, I get a better result. You can see that's right, is there already. Another way to do this is to use this indexing method. If I copy this code right here and say drives right to, it doesn't mean drive right to, instead of saying using this column name, I could say it should return all the rows, but it should return it from, I'm going to use a semicolon, this semicolon, the comma, let's return the last row, which is -1 here. -1 should work fine. Let's see from the left. So if I call on drive right, oh, -1 won't work. So I could just use a code here, 0, 1, 2, 3. Should you see that column as 3? The third column or the fourth column? Let's see. The slicing is not working. Why is my slicing not working? Let me see. So how to slice it using slice? Oh, let's use 2. Wow. Hold up a minute. So there are 2 ways to extract. Okay. If I want to use this idea, you have to use uh there's another method to use. Let me get the method. I have to use lock. Okay, when you're doing I lock and B lock. Okay. Let me just say dot I lock. It should work now. Let's see. Aha. So I didn't include this I lock. There's a technique we learned on one particular live stream. You can see. So I'm getting same results. So this is the alternative using I lock and lock. So try to watch that video on I lock and lock to practice the same technique. But that is by the way though. So let's continue with the code. So use dr to subset cars. Okay. Use dr as a Boolean series to subset the cars data frame. Store the resulting selection in cell. Oh, let's see that. subset cars. How do I do that? Okay, use DL to subset cars. What do they mean by that? Okay. Okay, use DR as a Boolean series to subset the car's data frame. Store the resulting selection in cell. We want to subset car's data frame. I need to understand that word there. Subsets. So I don't quite understand that keyword there. Okay, let me think. Mm, okay, it says drive right is a Boolean column. So you have to extract it as a series. Then use this Boolean series to select observation from cars. Use this Boolean series to select observation from cars. What observation from cars? Let me pay attention. Let's look at the Boolean series again. Do we just want the two section, the two results? Okay. Let's see. So I need to understand that idea. I'm not getting that question correctly. Okay. So to subset, I think I need to use this variable here and say cars. Okay. Then open square brackets dr. Let's see. Use dr to subset cars. So let's see. Let's see the results. So I'm not going to print select. Okay, let's see it here. Okay, let's see. Okay. So if I print select now as a variable, let's see what is going to return. Oh, understood. I got the idea now. So once I use select, so it's only going to return the correct result with that drives right. Okay, extract drives right column as a series, which is storing it as zero equals to cars. Because we have it as a series there, not as a data frame like this. So from that, so we use it to subset cars because of cars in another variable. Use the out to subset cars as a variable called select. So we're going to say select. So it's going to return only the true result and ignore the false result there. Okay, understood. Now let's print cell. If I print cell here, so we should have print cell and understand that drive right is true for all observation. Okay, you can see true. Oh, interesting. We figured it out. Okay, great job. Interesting there. So driving right two. We have one more challenge to go. Driving right two. So the code in the previous example worked fine, but you actually unnecessarily created a new variable dr. You can achieve the same result without this intermediate variable. Put the code that computes dr straight into the square brackets that selects observation from cars. Okay, now we created two steps here. We can actually do that directly. So convert the code to a one-liner that calculates the variable cell as before. So let's convert the code to a one-liner that creates the variable cell as before. Okay. So how we're going to do that? We're going to say, let's convert this code to a one-liner. Okay. Sell DR as car. So the steps to do that will be okay. Hold up a minute, hold up a minute. How do you convert it to a one-liner? Let's think. So I want to convert these two steps of code, this DL cars drives rights, select DL cars into a one single code. Okay, and we are going to get same results. Okay, let's see it in action. Okay, the code that composes DL straight into the square bracket, the select observation from cars. Okay, okay. I think we figured it out. Let's see. Okay, hold up a minute. Let's see. So that is right. So Control C, put it here. I'm going to wrap it in another square brackets. Let's see if this is going to work. I'm going to try it out in my Jupyter notebook first. Let's see it in action. Ooh, we get an error. It says you forgot invalid syntax. Perhaps you forgot a comma. A comma where? A comma where? A comma. Actually, I doubt. Let's see it in action. Let me run the code here first. There's a silly way to run the code. Okay, let's explain this error. Oh, I've seen my mistake now. We want to convert it to a single line of code. Hold up a minute. It says the code in the previous example worked fine, but you actually unnecessarily created a new variable. So this variable that we created, we want to get rid of it. Okay. Now it says, oh, I want to get rid of that variable. So I still have that variable right here. So this is what I'm going to do. Okay, let's see. This is what I'm supposed to do. Let's see that. Then one more bracket here. Okay. Class drives right in cell. Let's see it in action here. Let's see now. Fantastic. So instead of creating a variable called dr as earlier before, so you just wrap it in cars. You can see because I wrap cars in drives right. I also wrap cars in dr. So rather than mentioning cars twice, I just run it. So let's click on cell now. Let me just name this on cell 2 so it makes sense. Select 2. So you understand the difference between those code. So click on cell 2 now. So let's run the code one more time. All right, cell 2. I should get same result as cell 1. But this time around, I'm getting it as a panda series also. Why? Why? Getting it as this. We're not supposed to get it as this. Okay, well, that's by the way though. Let's see. Let's see. Let me see this right here. Oh, so we got it as a panda series. Okay, let's submit the code first. Incorrect submission. It seems your code still contains a line dr to create variable dr. The point is to get rid of dr. Okay, let's delete this dr. Let's run the code one more time. Okay, now we have it alone. Ooh, it says you can use cars, that's right. So do I have to mention cars 2 times? I think so because it is still converting it to a pandas a series rather than a pandas data frame. So let's add cars again here. But this time around, tap it in quote again. Let's see. It worked. Ooh, but look at it. It's still almost the same thing though. So we're getting the same results. Cars per capital, country, drives rights. Interesting. So cars. But when bricks did okay. Bricks. So the best option is to mention your variable twice. That's how it is going to work. Okay, figure it out. I'm going to mention cars one more time here. Cars, then one more square brackets. Let's run the code again. So I have it as a good result like this. Nice one. Cars contains 7 rows of observation. Cell contains 4. So in the majority of the countries in your data set, people drives on the right side of the road. Interesting. That's how we converted it to one-liner code. Cars. Hmm. If you don't practice these things, you get to forget it. That's interesting. Okay, let's try this with cars per capital. We have 2 more challenge to go here. Cars per capital. Let's see. So it says, let's stick to the cars data some more. But this time you want to find out which countries have a high cars per capital figure. In other words, in which countries do many people have a car or maybe multiple cars? So similar to the previous example, you will want to build up a Boolean series that you can then use to subset the cars data frame. Select certain observations. So if you want to do this in one liner, that's perfectly fine. But let's do it 2 times. Then we break it down into one liner code to also practice it over and over again. It says select the cars per capital column from cars as a panda series and store it as CPC. Create a car mini observation that have a cars per capital over 500. Okay. So the first option is to store it as a CPC equal to the cars per capital data frame. It's going to be cars equals to, nope, not equals to anymore. Open square brackets. You want to select the CPC column, not the CPC, cars per capital column as a pandas data frame. So let me try it out in my Conda navigator here. So I call on CPC now. Let's see what gets returned. You see, we have this column returned here. Cars per capital 809,731, 809,731. So that is as a pandas series there. So let's break it into steps. We've done that. Use CPC in combination with a comparison operator and 500. You want to end up with a Boolean series that's true if the corresponding country has cars per capital of more than 500 and false otherwise. Store this Boolean series as many cars. Okay, many cars. Let's call this many cars equals to CPC. So it's going to be CPC. So it says use CPC in combination with a comparison operator and 500. You want to end up with a Boolean series that's true if the corresponding country has a cars per capita of more than 500. Okay, greater than 500. Let's see that in action. Let's run the code. So if I call many cars here, many cars, I'm still returning true, false, false. But it's supposed to return, you want to end up, okay, you want to end up with, we are correct. So you want to end up with a Boolean series that's true if the corresponding country has a cars per capita of more than 500 and false otherwise. Store this Boolean series as many cars. So we nailed it here, you can see true, false, false for each country. Then finally, use many cars to subset cars, similar to what you did before. Store the result as car maniac. Now let's create car maniac. Use many cars to subset cars, similar to what you did before. Store the result as car maniac, which is going to be equals to. Now let's see. Let's recap real quick. I'm going to be CPC. I'm going to wrap it in cars first, open brackets, CPC, open brackets, many cars. Let's see. This is going to make sense. Let's see. Control C. Well, I'm going to add more. Oh, we're going to get into an error. Let me see my mistake here. Cars, CPC, former brackets, cars, maniac. Let's see. Incomplete inputs. Ooh. Hold up. Let's see, greater than 500. Ooh, what's wrong? I'm missing something. What am I missing? Let's ask. Let's print car maniac. Yeah. Let's see if I'm going to get an error. Good. It says none of. Okay, let's explain this error real quick. This terminal is going to jump to many cars. Since we use CPC for many CPC for many cars, so I'm supposed to jump to car maniac streets. Let's see that in action. But is it only false? Wow. Okay, let's see. Okay, let me copy this code here. Cars maniac, cars, many cars. But I definitely want to try it out as a single line of code. Let's see. Many cars. If I call on car maniac now, car maniac, I'm getting true, false. No, okay, I'm getting cars per capita greater than 500, which is this many cars there. You can see them here greater than 500, which is just US, Australia, and Japan. US, Australia, and Japan, they are greater than 500, while the rest are less than 500. So this is absolutely true. So, but what we want to use it in a single line of code. Let me give this a shot. Okay, let's submit the code first and see. Oh, we need great job. The output shows that US, Australia, and Japan have cars per capita over 500. But what if we want to use it in a single line of code like we did earlier? Let's try it again in a single line of code. CPC cars per capita, the many cars, CPC greater than 500. Those are for many cars. Then car maniac. Let me give it a short. Car maniac 2, which is going to be CPC. So it's going to be just like this. Cars. There's going to be cars, open brackets, cars. Then I'm going to point to my condition, which is this condition here. Hold up, where's that condition? Okay, the first one is going to be this cars here. Then I'm going to create another cars in between. No, if I add too much, that would be too much. There is going to be greater than 500. Then we can close the brackets. So this should work fine as a single line of code. Let's give it a shot. Cars per capita greater than 500. Let's see. We nailed it. So if I call on car maniac now, car maniac 2, we should have same result as this. Yep. So this, I think a single line of code actually makes it easier. So cars per capita greater than, you can see cars per capita. Since our CPC is cars per capita, and many cars is CPC greater than 500. So I just point to cars per capita greater than 500. Pretty straightforward there. I think the second line of code works fine though. And let me copy this onto C. And let's reuse it on this place. So where I was saying cars, many accumulations, say this on the code. So we have same results. If I submit this line of code, we know this. So as a single series line of code is interesting rather than many steps. I'm starting to see though. Now let's finalize the last part of this challenge, which is cars per capita 2. This last part here. Oh, we're an hour, just an hour over. So the cars per capita. Remember about NP logical and NP logical or and NP logical nots, the numpy variant of the and, or, and not operators. You can also use them on Panda series to do more advanced filtering. Let's see how we can use it to do more advanced filtering. So take this example that selects the observation that have a cars per capita between 10 and 80. Try out this line of code. Try out these lines of code step by step to see what is happening. Okay, let's give it a shot. This last part, just a second there. Let's see what we have here. Now let's finalize this last part of the challenge and see what we have here. Okay, CPC cars per capita between NP. Okay. Okay, let me copy this line of code. Okay, let me try it out on my Jupyter notebook to see what's happening. Okay, CPC equals to cars per capita between NP logical and CPC greater than 10 and CPC less than 18. Medium is cars between. Oh, okay, you should try it out one at a time. Okay, let me try it out one at a time though. Control X. I have one CPC here also though. So I have to make this CPC. Just put the CPC 4. Let's run it again. CPC 4 for this scenario. I'm going to get past capital series, then between equals to, let's see. So between CPC 4, I'm going to put 4 here. CPC 4. So I column between. Can see between is going to return CPC that is between 10 and 80. 10 and 80. Between 10 and 80. You can see this is false, false, false. This one is between 10 and 80. This is 18. India 2. Then 200 is false. This is 2. 2. Okay. This is what is between logical is doing. And finally, medium cars between. Medium equals to cars between. Okay, let's see medium. Medium, you can see medium. So this cars between this series, okay. 18, 17, and 45. Oh, interesting. Now let's create same scenario using this example. So use the code sample provided to create a data frame medium that includes all the observation of cars that have cars per capita between 100 and 500. Print out medium. Okay. Okay, okay, cool. Use the code. So cars per capita. So CPC is going to be equal to cars. Okay. Cars between. So we want it to be in a single line of code. Oh, okay. Let's see how we can make it a single line of code. So let's make it a single line of code. So it's going to be NP logical and let's just use it straightforward. NP logical and. So I'm going to use the same thing, the same logic here. NP logical and open brackets. So it's going to be CPC. So I'm not going to copy this class per capital. So it's going to be hold up, hold up. Class per capital. I'm going to copy this line of code here. Class per capital greater than 10. Greater than 10. Then comma. Class per capital less than 80. Less than 80. Let's see this line of code now. Boom, you can see we get same results. You can see, so I get the same result. So rather than just making it like that, I'm going to frame it to, let's say, med. Let's just say med equals to this. So you get, so if I call on med now, I'm going to get same results. But I want it to be in a data frame. How can I make that to be in a data frame? Oh, to do that, it's quite straightforward. I'll just wrap it in square bracket like this. Okay, now that makes sense. You can see two, two. So you're going to only return these three results for us here. If I call on med now. Wait a minute. Nope. Oh, this is how we're going to get the result. 2, 2, 2. Okay. We may not get it as we want like this. We're going to get the result like this. The same result we tried to get here. This India, Morocco, and Egypt. We have it here, India, Morocco, and Egypt, using one single line of code. So we're supposed to use same single line of code for this that challenge here. So I'm just going to copy this code, Ctrl C, and use it on same, create a medium observation, Ctrl V. So use code sample provided to create a data frame medium that includes all the observation of cars that have cars per capita between 100, 100 and 500. Greater than 100 and less than 500. So between 100 and 500. So we're going to call it medium. I'm going to call it medium. So if we print out medium right now, print medium, the code should work fine. Ooh, medium is not defined. Hold up. Medium is defined. Look at my medium. Create a medium observation with cars per capita between 100 and 500. I close it right here. So let me explain this error. Okay, I'm going to say medium equals, so I can't use this same way like this on Jupyter on their interface here. Let's run the code again. Then we have this result here. So if I copy this same code here, code snippet here, and make use of it on Jupyter Notebook right here. So if I equate it, let's see if I equate it. So if I call on medium now, oh, I have many mediums here. I'm going to call this one medium 3. If I call on medium, I see I should have same result here as this false, 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 true. Only one true, which is true for this between 100 and 500. Between 100 and 500. Let's see. 100 and 500. This is 800, 700. This 500. So the only one here is Russia 200, which is true here. Now we have one true result here. Oh, interesting. So we knew that. So we got it correctly. So that's how to use it to solve the challenge. Let's see. I didn't put the code description. So next time if I'm going back to the code, I can always read the description. So I understand what my code is doing. Okay, so that's all. I think we've solved the whole challenge. Ooh, did you define CPC without errors? CPC, we don't need to define a CPC again. I used a single line of code immediately and I got the result. Why do I need to define CPC one more time? Use the code Example, so I'm supposed to define CPC. Okay, let's define CPC just for following protocol. Okay, CPC equals to this between, I'm going to create another one called between. Oh, so we have to follow the example though. So let us follow the example, this same code. So our between is now going to be this NP logical code here. Control X, let me just get rid of it. Then medium is now going to be class between, then between. Let's run the code again. So you can see it's returned just a single answer. So same thing they wanted us to do here, but in this place we got medium. I didn't get a straightforward answer. So if I want to get a straightforward answer, I have to use it one at a time to get a single result out. Okay. If I run this code here, I'm just going to make my medium 4 here. Exactly, medium 4. If I print out medium 4 now, it's going to return a single result, just like this. Oh, not like a standard data frame like this. So that is different though, but it still works fine. Running the code one at a time, depending on what you are trying to achieve. Okay, so same results. You can see. Okay, so we nailed it. So that's how to use all these logical operators, control flow and structure to filter, control your data sets. Wow, interesting. That's a pretty long one there, but we have no choice. So I'm moving to while loop. Not today, definitely not today. That should be on day 13. All right. That'll be the live stream for today. Right. So thanks for staying to the end of the live stream. So if you found value learning this Python, join in this Python learning journey with me. So do well to support the channel by giving the video a thumbs up, hit that subscribe button, and I'll see you on day 13 live stream when we jump on to loops in Python and understand how looping works in Python. So I hope you enjoyed this control flow, filtering and structuring. It's pretty intense, just have to be patient while running each line of code one at a time. As usual, do have a wonderful rest of the day, and I'll see you on the next video on the channel. Go watch the previous live stream if you are new to the channel and looking to get your hands dirty with good practice about Python. Definitely, you're going to enjoy learning Python with me. I'll see you on the 13th. Peace out.